Good morning, everybody. The goal of my talk today is to kind of go through what our platform is, as Lucas was saying, our deployment strategy, how we do things, and how we came about to solving all kinds of different problems and come up with all kinds of cool solutions with deploying large-scale applications in AWS. As well as our sort of our learning experience with Chef as well. So hopefully you guys find this interesting. Again, I'm John Martinez. I work for the Adobe Cloud Services team. I'm a manager there, and I have a really small crack team of cloud professionals. Our goal is really to work on cool new stuff. And we basically take that cool new stuff, that new technology, and build operational best practices around all of that cool stuff. We also show our different development teams how easy it is to get up and running in AWS and with Chef. One other sort of snippet that I'd like to say about myself is that working at Adobe feeds my personal habit, which is photography. So at the very least, I don't have to spend money on software, and I can concentrate on buying more photography gear. Um, Cloud platforms at Adobe. Adobe's grown pretty large in terms of our cloud platforms. There's a few of them on this page here, and I'm not going to go too deeply into them. Just to say that my view of the Adobe world is surrounding Creative Cloud and a lot of the ecosystem around Creative Cloud. As you can imagine, Adobe is a pretty large company. We have hundreds and hundreds of business units throughout the company. So one of the things that's common at Adobe is that we don't really have mandates on our development teams. Development teams are free to use any technologies they want. They're free to use any provider they want. But really what our strength is in terms of my team and what we provide is sort of that centralized knowledge pool of how to really get efficient with using AWS, how to get started using Chef, and really we've built a practice around that, and it really has tightened down the amount of usage of other quote unquote stuff around Adobe. So it really has tightened what our tool sets and our providers look like. How did we get started? So Creative Cloud, which I'll be concentrating on, is relatively new. We went live in April of 2012. As a point of reference, I got hired on in June of 2011. If any of you have ever worked at a large software company, you'll know that having something from concept in and around May of 2011 to full production mode in less than a year later is a big feat. And actually, we Adobe has a pretty large conference ourselves called Adobe Max, where we go and present different Adobe technologies to our customers. We actually presented the Creative Cloud to them in October of 2011. So if you really think about it, from the time that I got hired on to the time that we went to the Adobe Max conference, that was only about 4 months. So we had to get up and started and going really, really quickly to show something off at our conference. And another point of reference, I was big that when I started those conversations around June, July of 2011. So we really are, I guess you could say, a poster child for how to take something really large, a really large idea, and implementing rather quickly. But to get there, we had to make some pretty big assumptions. So the first decision that we made was technical as it was a time to market decision. Management had taken a look at the landscape of providers, we really didn't see anybody who could allow us to scale and grow that large from the get-go. So that was one of the assumptions. The other assumption that was made, and this was actually my call, was to use Chef. Again, we have from the operations perspective, we didn't have a very large team, and we still really don't have a very large team. So pouring a lot of development time into all kinds of different tool sets and things like that was going to be really costly for us. So we figured that choosing a configuration management tool, a deployment tool that would help us get there, like Chef, was a great idea. So needless to say, for those of you guys that are familiar with AWS, autoscale was a large requirement for us. We knew going into it that we needed to have that elasticity. That's the only way we were not going to burn up a lot of operators' times. As well as we really like the idea, and I'll go into a little bit later, of using code-based provisioning tools. Again, shorten the amount of time that was required by operations engineers to be sitting in front of a console or anything like that. So those were the assumptions that we got started. And again, we had a very wide open field of choices. We really had nothing. So we had to make all of those decisions in a really compressed timeline. We started deploying. This wasn't really necessarily chosen at the very beginning. We played around with quite a few different things, but by the time mid-2012 rolled around, we came out with this formula of our deployment chain, and it's been working generally pretty well for us. We've made a lot of refinements along the way. So we start with Git as our source code management tool, and we really like the fact that it's very pluggable into tools like Jenkins. So Jenkins is not only our continuous build tool, we're also using it for continuous deployments. And the other piece of the puzzle there from the Amazon platform perspective is we've really taken an adoption and a liking to AWS CloudFormation. And I'll get into a little bit deeper on that, as well as hosted Chef. So we are big proponents of doing things using SaaS services. So the fact that Chef actually had a hosted platform was really good for us. We didn't want to go mess around with building Chef servers ourselves, although I'm sure a lot of you folks out there are building your own Chef servers, and that's great. We really, again, time to market was our driving factor here. So we had to get up really quickly. We had to really mainly our two hosting providers there, which is AWS and Chef, to make sure that we had a rock-solid platform for deployments. So what is our foundation today? What does that look like? So when we build our environments, it really is a threefold process. So the first part of the foundation is our base AMI. So we take Amazon Linux AMI and we use Chef to build in a base set of packages, etc. All of our different products that are going to be common throughout all of our different services. So we use Chef to basically help us bake that AMI. Now, we don't necessarily bake everything in, and I'm going to touch on that a little bit, but just know that Chef is an integral part of that. And once we've spit out the AMI later on in the process, we'll actually build the application stack on top of the AMI. The next step is we actually build our VPCs via CloudFormation as well, again, using the mantra of code-based infrastructure. So CloudFormation allows us to build virtual private clouds in AWS and really take in a lot of those different CloudFormation parameters to assign things like IP address ranges and routing tables and security groups and things like that. So again, the fact that CloudFormation allows us to build something as fundamental as a VPC is really good for us. And at the very top or bottom, I have it here on the bottom, but at the very top, at the very end of the foundational pieces that we have is we'll actually build our application stacks again via CloudFormation. And that's where sort of our secret sauce, which is not so secret, but I'm going to share with you guys today, is the application stack. So these are our different applications that run in AWS in different services. And an integral part of that, again, is CloudFormation and Chef. And we'll go into what that deployment workflow looks like in a little bit more detail. So a data center in AWS, yes, we have those three different layers that I just talked about. Some you can akin that to a taco, where the base, the bottom, the tortilla layer is the VPC. That's where we actually build all of the base common networking infrastructure in AWS. Those of you guys that have been old hats in AWS know that VPCs are in, EC2 Classic is out. So some of you guys have probably gone through the pain of moving from EC2 Classic over to VPC. We've done it in some places. We're doing it now at this moment in time. We're doing it on a really large scale deployments. We're converting all of that. It's not necessarily easy. It's not the hardest thing in the world, but when you're using something like CloudFormation, it really helps out to get there and to convert yourself from EC2 Classic over to VPC. We also deploy our ELBs, security groups, etc., into this layer using CloudFormation as well. And at the tail end, the application stacks. This is again where the rubber meets the road, and this is how we actually do our deployments. AMIs. There's different schools of thought here. Some people like to bake in or put all of their packages, their application packages, etc., into an AMI and boot an AMI. There's some advantages to that. One of the advantages, obviously, is the speed of boot time. So you get really fast boot times and startups of your application stacks. One of the things that's on a drawback to that is that it's not as flexible. You have to become kind of an AMI librarian of sorts, where you have to really manage your AMIs well, as well as come up with an automation platform to build your AMIs. You really don't want to get into the business of an ops or a DevOps engineer building AMIs by hand. That's not really a good use of time. So those are the drawbacks. And on the flip side, you can do a lot of runtime configurations. And that's where, again, Chef is usable, very usable in that regard, where you have base minimal AMI that you boot up. One of the things, for example, that we build into our base AMI is the Chef client. As part of that, we've actually written our own custom bootstrapper for Chef's client. And at boot time, we basically configure the applications using Chef and start up the applications. So a little bit slower boot time. So we fall somewhere in between that. For the most part, we like the flexibility of configuring our applications at boot time, although and I'll talk about it at the end of my presentation, where we are looking at speeding up some of our processes for our larger application sets. Why do we love CloudFormation? If it hasn't been evident so far in my talk, we like it because everything is code-based. We write the JSON. We actually spit out from Jenkins. We spit out our CloudFormation templates from templated templates, if that makes sense. So we actually modify our CloudFormation templates in a Jenkins job, and then upload it to the CloudFormation service. And really, a lot of what's in that template is we'll change some of the attributes to match our build IDs and things like that, like our Chef environments and those kind of things. So as we send that along to the CloudFormation service, it's sort of a thing that we modify in line. And we source manage our CloudFormation templates just like everything else. And almost everything we deploy as a stack. As a matter of fact, I was talking to one of our DevOps engineers not that long ago, and one of the applications that I thought, man, these guys are never going to go to build a CloudFormation stack out of this, or build chef recipes out of this. They've actually gone and accomplished that. So I'm very pleased about that. And infrastructure truly is code. I wonder who coined that phrase a year or two ago. And why we love Chef. There's just some things that we like to do at boot time, or at runtime, or at the time we build our AMI. And in the cases where we do build applications into the AMI and we boot them up automatically via CloudFormation and autoscaling, we actually really just use Chef in those cases to maintain state of that application. So for example, if we've built an application and configured an application ahead of time using Chef, at runtime, what Chef does is make sure that that the state of the application truly is what it is, and that there it basically tells you that we use Chef Client and we run Chef Client on a continuous basis on our EC2 instances. It's really important for those of you guys that may be going through some security compliance frameworks. I know we're going through a lot of that ourselves these days. It's really important to be able to show your auditors that, yeah, hey, the state of my applications and my servers are what they are because I have something like Chef running. Environments make things very flexible. We are huge proponents of Chef environments. We really love Chef environments. It allows us to have a common set of a commonality between our cookbooks and just really easily override our node attributes using environment attributes. So it's very easy for us, and that enables the third bullet point there. It allows us to replicate our cookbooks across dev teams pretty easily. And we basically just show the dev teams, or DevOps engineers show the different dev teams how to override those different attributes in an environment file. And one of the things that was a little rough around the edges, I'll be honest with you, at the very beginning, was how we had to beat Chef into submission with EC2 and CFN. We don't use knife EC2. We're, like I said, we're huge in CloudFormation and autoscale, so kind of making the two work together was a little bit rough at the very beginning, but we've come up with a pretty good system thus far that's worked well for us. And we're able to use the best of all worlds, both with the infinite scalability, seemingly, as well as the automation that Chef brings to us. So how do we make it work? It begins with Jenkins. Actually, if you go look at my previous slide, it really begins with Git. And in a subsequent slide, I'll kind of go through the workflow, but with Jenkins, we do the automation for our applications, our application builds, our AMI builds, our VPC deployments, our application stacks, and it ends with Chef. And it takes us all the way to an application running, including up to actually Chef setting up so that our health checks and all of our automated testing that goes through at the end of a deployment all just works. And I'm oversimplifying a lot of this. This takes quite a bit of work to get there, and it takes a lot of hours. So be prepared. It takes a lot of hours, and really one of the things we were talking right before the session is how distributed Adobe is. I didn't talk about this in the About Adobe slide, but we have teams that we work with. These are both operations, DevOps, dev throughout the world. I myself am based in the Bay Area, but we have teams in places like Hamburg and Noida, in Bucharest, Romania. So we've got folks all over the place that have their hands in the kitchen, as it were. So having all of these different workflows and development workflows really enables us to get there where we have these distributed teams throughout the world. What's a typical deployment workflow look like for us? So first, we have Git, and this is in places where we have actual continuous deployments. Now, a caveat here is we don't actually deployments happen in dev. There are some places we do our production and pre-production environments are deployed by hand. We're still using the exact same tool chain. It's just user initiated as opposed to initiated by in a continuous workflow would be a Git webhook to Jenkins, for example. So we'll go through that. So Git triggers a build via webhook to Jenkins, and as part of that, that Jenkins job, we do a couple of things. One is we'll do a knife upload of our cookbooks if there's been changes, of our environments, of our roles, our data bags. We're big proponents of encrypted data bags, so we do use encrypted data bags for passing in different credentials that we might need in our EC2 instances. So this things like databases. In the past, we've done things like our AWS API key and secret and things like that. So we use data bags heavily in those cases. The other thing that Jenkins will do is it will take that templated template, if you will, for CloudFormation, modify it for that particular build, and basically start an application stack in CloudFormation. And as part of the CloudFormation stack, we will build an autoscale group. And that autoscaling group will in turn launch all of our EC2 instances. And what happens at that point? At the time that EC2 instance boots up, or set of instances in the autoscaling group, we'll actually go and download from S3 our Chef validator key, and we'll authenticate to the hosted Chef platform, and we'll get all of as part of inside of the AMI, as I talked before, we have our special bootstrap script. We'll as part of the boot up process, we'll grab whatever the Chef client will grab whatever data bags and recipes that we need for that particular application. And we also host our application builds in S3. So part one of the recipes will come along and download the application build if it's not already baked into the AMI. And configure it and start it up. So again, this is where the power of environments works, and this is how we actually do promotions. So we actually do promotions of our different application builds by environment. So we are using the different cookbook versions in our different environments, and that's how we were able to quickly tell, not just by we do name our environments as well by platform and stage. So it'll, where one will be dev and pre-prod and prod, etc. So what is so special about what we do with the node identification as part of our bootstrapping? Chef node attributes are sent to opscode hosted platform from Jenkins, and instances start up from the autoscaling groups via CloudFormation. The Chef node role and environment names are sent to instances via the user data service, and so that's part of the secret sauce. So the bootstrapping script will actually take the role that comes from user data and configure the node name that way. As well as the environment as well. So in the run list, it'll create the run list based on the user data information that it finds. And the validator key, as I said before, is stored in S3. And one of the newer things and we're actually converting a lot of our AWS accounts to, is to use IAM roles for EC2. So the really nice thing about IAM roles for EC2 is that it allows you to get away from passing in credentials, API credentials into your EC2 instance. So really highly recommend going that way. I will be honest, one of the challenges is that if you're using any of the public AWS cookbooks, a lot of them are a little bit are behind in supporting IAM roles. So I'll talk a little bit about that in one of my later slides. So just be aware of that. And then the application is running. And that's basically it. Here's a code example of what the CFN CloudFormation template looks like. And as you can tell, there in the bigger text, those are basically the attributes that we send down into the instance via the user data service. So chef role, chef environment, chef organization. This is kind of interesting. In a case like ours, we actually have many different chef organizations. So those of you guys that are using enterprise chef or hosted chef have the ability to have multiple, not just environments, but organizations as well. So we actually use that pretty heavily because we want to have a level of isolation between our different products. So that way, we will share a cookbook from one organization to another, for those of you guys that have figured this one out, one thing I am looking for is an easy way to manage cookbooks between organizations. So that is a need that we have that we haven't quite figured out as well. But in today's world, we'll actually go and basically copy a cookbook from one Git repo to another one, and synchronization becomes a little bit of an issue, and that's kind of what I'm getting at. The chef, having multiple chef organizations allows us to have that level of isolation from product team to product team. These different attributes will then tell the bootstrapping script how to go and talk to the chef, the hosted chef service. So in the next slide here, I have a chef environment example. If you look down in there, we basically have a ton of different node attribute overrides that we have as part of our chef environment. One of the secret sauces, or one of the things you can use as part of environments, is cookbook version overrides, which is really where the power of chef environments comes from. So we use that, again, really heavily, and that's how we do the promotions between our different environments. Second. What are we doing in terms of continuously improving ourselves? We all talk about continuous deployments and builds and all that stuff. But one of the things that should be part of your program, your DevOps program, is continuous improvement. Never stop. Never stop improving. Never stop iterating. It's part of life. It is what it is. In our case, one of the things we're looking at, like I said earlier, is baking more into our AMIs and having Chef maintain consistency in our nodes. The other thing that we're looking at, and this goes back to the comment I made about support for IAM roles, is we're looking at moving to the AWS SDK for Ruby. For our AWS specific recipes. So this would be things like talking to S3, for example, or ELB, or the different APIs, AWS APIs. One of the things that we're about to switch over to is Route 53 weighted record sets for A/B deployments. I didn't get too much into the fact that we do A/B deployments. So we have a running deployment, and we start up, for example, that would be A. We start up a B deployment, and we run automated tests. And then once we're satisfied that the tests are successful, we will cut over to the B deployment and basically terminate all of the instances that make up the A deployment. So we treat our deployments as ephemeral, meaning that we can just trash it once we're done with it. And that's obviously something that you have available to you as part of AWS. And the other thing that we're looking into is moving our deployments closer to AWS, where we have a Jenkins master or masters inside of our corporate network. But as part of a deployment, we'll push and create Jenkins slaves in Amazon itself, in AWS itself. So what's really nice about this, again, we're targeting these automated builds of Jenkins slaves using Chef as well. So again, we're utilizing all of our tools to their fullest extent. Um, and a couple of secrets revealed. We continuously build for the most part. We continuously deploy, but not for prod. Again, the feeling is that we want to have controlled deployments or user-initiated deployments into our production environments. And we continuously learn to make sure that things suck less for us. One of the things that really I take really heavily is when DevOps engineers or operations guys come to me and say, hey, this part of the tool chain really sucks. How can we make it better, or what can we do about it? So that really is a mantra that we keep. We don't really build our data center in 5 minutes. It does take a little bit longer. CloudFormation is done in a couple of minutes, but really it's all of the launching of the different EC2 instances and auto-scaling groups and attachments to ELBs and all that stuff that takes definitely a little bit longer than that. But if you really think about where we've come from, for those of you guys that have been in data center environments, sort of the classic deployment models, you'll know that deploying new hardware takes weeks, not minutes. So yeah, we build virtual data centers in really quick time and record time compared to that. It's not really 5 minutes. And that's all I have. So if you have any questions, I went through this rather quickly, but if you have any questions, if you're in the Bay Area and you want to offer me beer or other things like that, there's my contact info.